Hi friends, welcome to Talent Sprint's Banker's Choice program. In this session, we are going to learn about set theory. Set theory is generally asked either for 1 mark or for 5 marks in bank exams. And this is a very simple topic which can easily fetch you 5 marks in less than 2 minutes. So let us understand what is set theory all about. Set theory is a branch of mathematical logic which is used to study sets. And sets are nothing but a well-defined collection of objects. Let us first understand what are some examples of sets. Now, as I mentioned, a set is a collection of well-defined objects, right? Some examples of sets are as follows here. Now, for example, set of natural numbers. A set of natural numbers is denoted by n, which includes 1, 2, 3, 4 up to infinity. That means this set has got all the natural numbers. And each of this number here is called the element of the set. Likewise, set of whole numbers, which is denoted by W, has got the elements 0, 1, 2, 3 up to infinity. So this set has got all the whole numbers, that is numbers from 0 up to infinity, or integers from 0 up to infinity. Then we have set of integers denoted by I, which has got 0 plus or minus 1 plus or minus 2 plus or minus 3 and so on up to infinity. Then likewise we have set of even numbers and set of odd numbers, that is set of even numbers has got 2, 4, 6, 8 up to infinity, and odd numbers has got elements 1, 3, 5, 7 up to infinity. So all these are examples of sets. These are nothing but collection of some numbers, collection of well-defined objects, right? And here each of these numbers which belongs to the set is called element of the set. As you can see here in the first 5 examples, the number of elements in each of the sets are infinite. And hence these are called as infinite sets. For example, if you look at set of natural numbers, it is 1, 2, 3, 4 up to infinity. That means it has got infinite elements and hence it is called an infinite set. Likewise, in all the remaining cases, we have got infinite elements and hence all these are referred as infinite sets. Apart from infinite sets, the other type of sets that we have are finite sets, where the number of elements are finite. For example, let's say there is a set called A which has got the elements 1, 2, 3, 4 and 5. So there are only 5 elements here. 1, 2, 3, 4, 5. Likewise, there is a set B which has got the elements 3, 4, 6, 9, 12 and 15. So there are 6 elements in the set B. So these two are referred as finite sets as they have got finite number of elements. So these are finite sets. The other point that we need to understand here is a set need not necessarily have only numbers as its elements. For example, we can say that there is a set of all the letters in the English alphabet. So this set here has got the letters of English alphabet but not numbers as its elements. Likewise, we can say that there is a set of all Indians. So here the elements of the set are persons. Or we can say there is a set of Americans. So here all the elements in the set are persons from America. So this is how a set is nothing but a collection of objects, a well-defined collection of objects. It can be numbers or letters or persons or any other type of objects. Let us now look at some of the important operations that can be performed on 2 different sets. Let's take 3 different sets as follows. For example, the set A here has got 1, 2, 3, 4, 5 as its elements. Set B has got 3, 4, 5, 7, 9. Set C has got 9, 12, 15, 18 and 21 as its elements. Now here the first operation that we have is union of sets. Union of 2 sets A and B is denoted by A union B as shown here, and it is the set of all elements that is either in A or in B or in both A and B. So when we take A union B, we need to consider all those elements which belong to either A or B or both A and B together. For example, if we take the 2 sets A and B as shown here, A union B can be taken as 1, 2, 3, 4, 5, 7 and 9. Why? Because 1, 2, 3, 4, 5 all belong to A. 3, 4, 5, 7, 9 all belong to B. So collection of all the elements that belong to either A or B or both A and B is referred to as A union B, and it is denoted by A union B as shown here. Next one here is intersection of sets. Intersection of 2 sets A and B is denoted by A intersection B as shown here, and it is the set of all those elements that belong to both A and B. That means when we take intersection of 2 sets, we need to consider only those elements which are present in both A and B as well. So if we take A and B as the given sets here, A intersection B will be equal to 3, 4, 5. Why? Because 3, 4 and 5 are the elements which are present in both A and B as well. So intersection of two sets is nothing but collection of all those elements which are present in both the sets. Likewise, we can have intersection of three sets, A intersection B intersection C. So here we take only those elements which are present in all the three sets. So whenever we go for intersection, we need to take common elements of all the given sets. For example, let's say we have to find out B intersection C. Now in B intersection C here, you see that the elements which are common is only 9. 9 is present in set B as well as it is present in set C. So when we take B intersection C, the only element that we have here is 9. Or if we take A intersection C, if you take A intersection C, the elements in A are 1, 2, 3, 4, 5 and that in C are 9, 12, 15, 18, 21. You find that there is nothing common between A and C. So A intersection C will be equal to a null set. A null set is nothing but that set which has got nothing in it. Therefore, there is no object in a null set. So A intersection C here will be equal to null set. The next operation that we have here is disjoint sets. Disjoint sets, two sets A and B are said to be disjoint. They are disjoint from each other if A intersection B is equal to null set. So whenever there is no intersection between two sets, or whenever the intersection of two sets results in a null set, then those two sets are referred as disjoint sets. That means there is no connection between these two sets. They are completely disjoint from each other. There is no overlapping. For example, if you take these three sets here, the two disjoint sets that we have are A and C. But because A and C share no common element among them. So A intersection C is a null set, hence A and C are called disjoint sets. B and C are not disjoint sets. Why? Because B intersection C will be equal to 9. The set B intersection C will have one element 9. And hence they are not disjoint sets. So disjoint sets are two sets where there is no common element between them. The last one here is difference of sets. Difference of two sets A and B is denoted by A minus B, and this is the set of all elements that belong to A but not to B. So whenever we take A difference B or difference of two sets, we need to consider all the elements that are in A but not in B. Likewise, let's say we have to consider the difference of two sets R and P. So here R minus P denotes all those elements which are there in R but not in P. For example, taking these three as the given sets, A difference B here will be equal to 1 and 2, a set which consists of 1 and 2. Why? Because 1 and 2 are the elements which are there in A and the remaining elements, as you can see, are there in B as well. So we need to consider only those elements which are there in A, but that should not be in B. So as 3, 4 and 5 belong to B, it cannot be taken in the difference of sets. Likewise, B difference A will be equal to 7 and 9. Why? Because from B we need to subtract or we need to remove those elements which are there in A. So 3, 4, 5 are there in A. So B difference A will result in 7 and 9. And from this you can understand that A difference B is not equal to B difference A. A difference B is 1 and 2. B difference A is 7 and 9. So A difference B and B difference A are not equal to each other. And B difference C, let's take B difference C. So B difference C should have all those elements that are there in B but not in C. So if we take all the elements of B here which are not in C, we should remove 9. Why? Because 9 is the element that is present in set C as well. So the remaining elements can be taken as B difference C, that is 3, 4, 5 and 7. So that results in the set B difference C. So these are some of the important operations which can be performed on sets. Union of sets, intersection of sets, difference of sets, or what are two disjoint sets. And out of all these operations, the most important ones here are union of sets and intersection of sets. Why? Because when it comes to bank exams, the type of questions that we get involves either union of sets or intersection of sets. So make sure that you are very clear with what is union of two sets and what is intersection of two sets. Union of two sets is all those elements which are there in first set or in second set or in both the sets. Whereas intersection of two sets are all those elements which are present in both the sets, that is first set and second set as well. After learning about sets and the various types of operations that can be performed on two sets, let us now see how can these operations on sets be represented with the help of diagrams. Generally, we use Venn diagrams or set diagrams to show all the possible logic relations between a finite collection of sets. So let us see how can we show various types of sets and their relationships with the help of Venn diagrams. In case of Venn diagrams, a universal set is represented by a rectangle and a subset is represented by a circle within the rectangle. For example, as you can see in the first diagram here, the rectangle shows the universal set. That is nothing but the complete set or the total number of elements. And any subset is represented with a circle inside the rectangle. That is, a circle here is nothing but a part of the universal set. So as you can see, this complete rectangle, whatever comes inside the rectangle is the total number of elements. And whatever comes within this circle are those elements which belong to the set A. The remaining part of the rectangle here is shown by A dash, which is read as A complement. Now A complement here shows all those elements which belong to the universal set, but they are not a part of the set A. So as you can see here, the complete set, universal set, has been divided into two regions. One is the set A. So this shows all the elements that belong to set A, and the other region shows all those elements that does not belong to the set A, and is represented by A dash. Now the second diagram here shows how can we represent two disjoint sets. As we have learned, disjoint sets are those where the intersection is a null set. That means there is no common part between two disjoint sets. Let us understand this with the help of a diagram. Let's say the universal set here is natural numbers. That means universal set is nothing but all the numbers from 1 to infinity, all the integers from 1 to infinity. Now we know that all the natural numbers can be classified either as prime numbers or composite numbers except the number 1. So here, if we take one set as prime numbers and the other set as composite numbers, then the complete diagram will be as shown. Now, as you can see here, the universal set is all the natural numbers, out of which one part shows all the prime numbers and the other circle shows all the composite numbers. And we know that there is no common part between prime numbers and composite numbers. A number is either prime or it is composite. It cannot be both prime and composite at the same time. So that is the reason there is no overlapping between these two sets, or these two sets do not overlap each other. So this region shows all prime numbers. The other region shows all composite numbers. And the left out region which we see here is nothing but the number 1. Why? Because the number 1 is neither a prime number or a composite number. It does not participate in any of these two categories. So this is how we can show two disjoint sets. Universal set is natural numbers. One subset shows prime numbers, the other subset shows composite numbers. And the left out region can be taken as the number 1 as it is neither a prime nor a composite number. So that's how representation of sets can be done with the help of Venn diagrams. Remember, always universal set is a rectangle, and within that we can show various subsets with the help of different circles. If there is nothing which is left out after drawing the various sets, then we can say that this region will be equal to 0, or this region is a null set as there is nothing inside that region. Let us now look at the representation where two sets overlap each other, or there is a common part or an intersection exists between two different sets. For example, let's say the universal set here is the students in a class. Now all these students in the class is represented inside the rectangle. So this complete rectangular region shows the total number of students in the class. Let us now say the students of the class play hockey or cricket or both. And there are some students who do not play any of these games. So how do we represent such a case with the help of Venn diagrams? Now here, as already discussed, the rectangle shows the total number of students in the class. Now there is one circle denoted by capital A which shows the number of students that play hockey. So here the first circle is that which is talking about students playing hockey. Then we have a circle which shows the number of students playing cricket, and it is denoted by capital B. So these are the two circles here, or we can say these are the two sets, set A and set B. Set A here is all the students playing hockey, set B is all the students playing cricket. Now since we know that there are some students who can play hockey as well as cricket, we try to overlap these two sets, or we try to draw these two circles in such a way that they intersect each other. And that intersecting region, as you can see here, the intersection between the two sets is this part. So that intersection of two circles or intersection of two sets there shows those students who play both hockey as well as cricket. And the left out region, apart from these two circles, the left out region here represents those students who do not play any of these two games. So if we try to observe properly, we have got four different regions in the universal set. One region is small a, the other region is small c, then we have one region which is small b, and the fourth region here is small d. Let us now understand what does each of these regions represent from the given Venn diagram. Now if you observe, small a here is the region which shows students playing only hockey. As you can see, small a is only that region which is hockey but not cricket. That means if you remove the set cricket, left out region is called as hockey. So this is A, which shows the students playing only hockey. Remember, there is a difference between students playing hockey and students playing only hockey. If you observe, the students playing hockey, total here is A plus B. Why? Because whatever comes inside this circle is the number of students playing hockey. So what do we find here? A and B within the first circle A. So A plus B is the total number of students playing hockey. That is what is given here. Total number of students playing hockey is A plus B. But the number of students who play only hockey is represented by small a. This region, small a. Why? Because these are the students who play hockey but not cricket. So that is why they are called students playing only hockey. And there is a huge difference between both these cases. That means students playing hockey and students playing only hockey. So never confuse between these two terms. When we specify the word only, it means we are talking about students who play only that game and no other game. And when the word only is not given, it means the students there can play hockey as well as the other game. So hockey is A plus B, whatever comes inside the first circle A, and only hockey is the region A. Similarly, the number of students playing cricket is shown by the set B or the circle B. Now whatever comes inside the circle B is the number of students playing cricket. So B plus C or C plus B is the number of students playing cricket. But then the number of students who play only cricket is the region which is shown only by the part C here. So C is that region which shows the students who play only cricket. So students playing only cricket here is shown by C. So again, if you can observe, only cricket is C and cricket will be B plus C. Now this particular region B, which we have understood as the intersection part, shows that region who play both cricket as well as hockey. So students playing both cricket and hockey is shown by the region B. So that particular leaf-like structure which comes after the intersection of the two circles shows the students who play both hockey as well as cricket. And then as we have learned, the left out region D shows those students who neither play hockey nor cricket. So whatever comes out of the two circles here shows those students who play neither hockey nor cricket. So D is that part. Neither hockey nor cricket is shown by D. Now if you try to observe, the total number of students in the class is composed of four regions A, B, C and D. So we can say that total is equal to A plus B plus C plus D. Where A is the number of students playing only hockey. B is the number of students playing both hockey and cricket. C is the number of students playing only cricket, and D is the number of students playing none of these two games. Remember, it is not necessary that there should be some value for D. D can sometimes become 0 if all the students play at least one of the games. So depending on the question, we can decide whether D should exist or not. If each student plays at least one of the games or minimum one game, then none of the games region will become 0. So D there can be taken as 0. But otherwise, in general, total should be taken as A plus B plus C plus D. So in general, when we solve 1 mark questions, this is the formula to be used. That is, total number of elements or total number of students should be equal to set A, the number of students in set A plus number of students in set B minus those students who are there in both set A as well as set B. That is nothing but intersection of set A and set B plus none of set A and set B. That means this is the region which is out of both the sets or out of both the circles. So simply remember that total will be equal to A plus B minus both AB plus none, where A and B are nothing but two different sets. For example, as in this case, A represents the number of students playing hockey and B represents the number of students playing cricket. Likewise, in some cases, the two different sets are given in terms of coffee or tea. That is, some people have coffee, some people have tea. So in that case, we can say that total will be equal to set A plus set B minus both AB plus none, where A is the set representing number of people having coffee and B is the set which represents number of people having tea. So number of people who have coffee plus number of people who have tea minus those people who have both coffee and tea plus those people who have neither coffee nor tea. So always for two given categories, for two different sets, we can take total as A plus B minus both AB plus none. If you observe properly, the formula that is given here is quite similar to what we had learned in elementary set theory in school. That is, n of A union B should be equal to n of A plus n of B minus n of A intersection B. So that's like a mathematical equation, and here we have a simple formula in terms of A and B. The proof for this formula can be taken as follows. We know that total or the universal set here is nothing but region A plus region B plus region C plus region D. So why are we using this formula? How does it satisfy the given equation? Let's understand. Now as you can see here, this A here is the set A, and set A in the given diagram is A plus B. So it can be taken as A plus B plus the set B is nothing but B plus C minus both A and B is the region B, small b, plus none of A and B is the region D. So if we try to simplify this, we find that plus B and minus B gets cancelled, and we are left out with A plus B plus C plus D. So that's the proof for this formula. From the diagram, we very well understand that the universal set or the total number of students will be equal to A plus B plus C plus D. And from this formula as well, we find that the total comes out to be the same. Let us now take the first model from this topic of set theory, where we shall discuss a 1-mark question. As we have discussed earlier, generally when two sets are given to us where there is some overlapping between the sets, we can use the formula that is total equals to A plus B minus both A and B plus none of A and B to get the required answer. So let's look at this example and see how can we get the answer. The question here is, in a class of 120 students, 70 students passed in English, 80 students passed in Hindi, and 40 students passed in both English and Hindi. How many students failed in both the subjects? So as you can see here, total number of students are 120, out of which 70 students passed in English and 80 students passed in Hindi. So the two sets we have here are English and Hindi. One set represents the number of students who have passed in English. The other set represents the number of students who have passed in Hindi. And remember friends, the question says 70 students passed in English. This doesn't mean that 70 students have passed only in English. Out of these 70, there can be some students who have passed in English as well as Hindi. Similarly, here it says 80 students passed in Hindi. So it doesn't mean that these 80 have passed only in Hindi. Out of these 80, there can be some students who have passed in Hindi as well as English. And then it says 40 students passed in both English and Hindi. So 40 is the number of students who have passed in both English as well as Hindi. How many students failed in both the subjects is the question. Now try to understand, how many students failed in both the subjects means the number of students who have passed in none of the subjects. So here we need to find out how many of them have passed in none of these subjects. Instead of taking it as how many have failed in both the subjects, let's understand this is nothing but passed in none of the subjects. Passed in none of the subjects. So whether we say failed in both the subjects or passed in none of the subjects, it means the same. So we need to find out what is the none category here. Now there are two ways to solve this question. Either we can use the simple formula that we have discussed, or we can go by Venn diagrams. Now going by the formula, we know that total should be equal to A plus B minus both AB plus none AB. None of A and B. This is both A and B. Now simply by substituting the values here, we can get the required answer. We know that A is the first category. Let us take it as English, and B is the second category, that is Hindi. So let's substitute the values. We know that total number of students are 120. So we can say that 120 is equal to A, that is nothing but number of students passed in English, given as 70, plus B, which is number of students passed in Hindi, given as 80, minus both AB. Both AB is nothing but number of students who have passed in both Hindi as well as English, which is given as 40, plus none. Students who have passed in none of these subjects. That has to be calculated. Now by simplifying this, we get the required answer. So 70 plus 80 is 150, minus 40 is 110. So none can be taken as 120 minus 110, which is equal to 10. So we can say that 10 students have failed in both the subjects. 10 students failed in both the subjects. So that's the answer. So simply with the application of this formula, we can find out whatever is required. Total should be equal to A plus B minus both AB plus none of A and B. Remember, A here is the complete set A, B is the complete set B. It is not only A and only B. It is simply A and B. Now the alternate solution for this question can be done with the help of Venn diagrams. This is with the application of the formula, but if we try to go by Venn diagrams, we know that there is a universal set. Now here the universal set is nothing but the total number of students, that is 120. So the total can be taken as 120, which is the universal set. And here we have two different subsets, that is one subset is students passed in English and the other subset is students passed in Hindi. And as given in the question, 40 students have passed in both the subjects. So there will be some overlapping between these subsets. So let us try to take English and Hindi with the help of small circles here. So the first circle here is for English and the second one is for Hindi. Remember, this complete circle is what? The number of students who have passed in English. And this complete circle is number of students who have passed in Hindi. And the intersection region is that region which shows number of students passed in both English and Hindi. And apart from these two circles, the left out area represents those students who have passed neither in English nor in Hindi. As you can see, it is outside both the circles, outside both the subsets. So very clearly, this region is that region which shows number of students who have failed in both the subjects. Now by filling up the values in these four regions, we can get the required answer. Now let's see how to work on Venn diagrams to get the answer here. So first of all, we know that universal set is total set 120 and we have got two subsets. Now remember friends, whenever we fill the values in these four regions, we know that the four regions here are A, B, C and D. A is like students who have passed only in English. B is the students who have passed both English and Hindi. C is the students who have passed only in Hindi. And D represents the students who have passed in none of these subjects. So how many students have passed in English? A plus B. How many students have passed only in English? That is A. But because we are talking about only English, so it should be taken as A. Likewise, number of students passed in Hindi, B plus C. It takes the complete circle. But number of students who have passed only in Hindi should be only this region, that is C. Students who have passed in both the subjects, B. And students who have failed in both the subjects, D. Now whenever we fill the values in these regions, first of all, we need to fill that region which is overlapped by maximum number of subsets. Now as you can see here, B is the region which shows the overlapping part, overlapping of English with Hindi. So first of all, we need to know what is the value of B. Until and unless we know what is this region, we cannot fill the remaining parts. And clearly in the question it says 40 students passed in both English and Hindi. So we can say that B is equal to 40. So this region is 40. Now if we try to go back, we know that 70 students passed in English. That means this complete circle A plus B is equal to 70. From the question we know that directly B is equal to 40 and A plus B is equal to 70. So if A plus B equals to 70, we can say that A will be equal to 30. Why? Because B is 40. So A plus 40 is 70, A gives us 30. So I can say that students who have passed only in English is 30. Likewise, we know that 80 students passed in Hindi. How many students have passed in Hindi from the Venn diagram? B plus C. So B plus C is equal to 80. So from this we can say C will be equal to 80 minus B. 80 minus 40 is 40. So C equals to 40. That means 40 is the number of students who have passed only in Hindi. How many students passed in Hindi? 40 plus 40, 80. Only Hindi, 40. How many students passed in English? 30 plus 40, 70. How many students passed only in English? Only 30. That is how we look at it. Now, total is 120, out of which already 3 regions have been filled, 30, 40 and 40. So remaining value should go for D. We know that 30 plus 40 is 70, 70 plus 40 is 110. So if this region is equivalent to 110, left out should be 10. Why? Because total is equal to 120. So we can say that D will be equal to 10. So the number of students who have passed in none of these subjects or number of students who have failed in both the subjects will be equal to 10. So either we can go by the concept of Venn diagrams or we can use this simple equation, substitute the values and get the required answer. As you can see in both the cases our answer is 10. The other types of questions that can be asked here are how many students passed only in English? Only English is 30. How many students passed only in Hindi? Only Hindi is 40. Or how many students have passed exactly in one subject? How many students passed exactly in one subject? 30 plus 40. 70 will be the answer. Exactly one subject means it should either be English or it should be Hindi. So 30 plus 40, 70 will be the answer. How many students passed in more than one subject? More than one subject is 40. More than one subject here can be only 2 subjects. So that should be taken as 40. Suppose the question says how many students passed in at least one subject. At least one subject means it can be one subject or both the subjects. So we should take answer as 30 plus 40 plus 40 which is equal to 110. So depending on the question, we can find out the answer from the Venn diagram. But when the question is asked for 5 marks, where we have 3 different sets, like maths, physics, chemistry, or hockey, football and cricket, there it is always suggested that we follow the Venn diagram. Why? Because this gives the answer much faster. So we again try to take 3 subsets with the help of 3 circles, and the universal set is taken as a rectangle. And then just try to fill the values. Remember one important point, whenever we go for Venn diagrams, we first of all have to fill the region which is overlapped by maximum number of sets. And then we have to move outwards. So this is how you can get the answers for such simple questions using Venn diagrams or the formula. Let us now take the second model from the topic of set theory, where we shall see how to draw Venn diagrams for 3 given sets. Here again we try to represent the universal set with the help of a rectangular box, and each of the subsets is represented with the help of a circle. And the overlapping between the circle shows the intersection between 2 sets. So let's see how can we understand the case of 3 sets with the help of a Venn diagram. Now, as you can see here, the complete rectangular box shows here the universal set. Now this universal set is nothing but the total number of persons or total number of objects that we have in all the 3 categories together. Now if we try to see, there are 3 different sets. Set A, which is represented by the circle here, set B as represented by the circle, and set C again as represented by the 3rd circle. So A is nothing but one category of students, let us say. B is the 2nd category of students, and C is the 3rd category of students. Students or persons, as the case may be. If we observe this Venn diagram, we find that the total set or the universal set here has been divided into 8 different regions, and each of these regions is represented with a small letter. For example, as you can see here, A, B, C, D, E, F, G and H are the 8 different regions. So let us understand what does each of these regions represent. As I mentioned earlier, A, B and C are the 3 subsets. Capital A, capital B and capital C. These are the 3 subsets, and various regions have been shown in this diagram. So let us understand the meaning of each one of them. Now as you can see, the total of set A is nothing but A plus D plus E plus G. That means complete set A is comprised of these 4 regions. A plus D plus E plus G. So that's how it is given here. Similarly, the complete set B can be taken as B plus D plus F plus G. So that is what is given here, B plus D plus F plus G. Likewise, the set C, which is represented by this circle, can be taken as C plus E plus F plus G. So C plus E plus F plus G. That means when we have to find out what is the number of elements in A or what is the number of persons in A, we have to take all these 4 regions. Similarly, number of persons in set B, all the 4 regions have to be considered, which comes inside this set B. And likewise for circle C, we need to consider everything that comes within that 3rd circle C. As I've mentioned earlier, the keyword only plays a very important role. For example, when we say how many persons or how many objects are there in set A, we say the answer is A plus D plus E plus G. But let's say the question is how many persons are there in only A. In only A is what? This region. Only A is nothing but the region which is represented by small a here. This region. As you can see, this region represents only A. So that is what is given. Only A is the small letter A, is the region represented by small letter A. Likewise, only B. Only B is this region as represented by the dotted line. So it should be taken as small b. And only C is nothing but the region which is represented by small letter c here. So that is one point where we need to be careful. If the question is about A, we need to consider A plus D plus E plus G. And if the question is about only A, then we take only small a. Likewise, if the question is about only C, we need to consider this small region which is represented by small c. And only B should be taken as B here. Apart from these 3 regions, A, B and C, the other regions here are D, E, F, G and H. So let us now understand what does each one of them represent. Now if you observe D and G, this complete leaf as represented by D and E, this is the region which shows overlapping between A and B. So the overlapping between the 2 sets A and B is shown by the regions D and G together. So the number of persons involved in both A as well as B should be taken as D plus G. So both A and B is taken as D plus G. Likewise, the region which is represented by both B and C is nothing but G plus F. This overlapping part, intersection part is G plus F. So that is nothing but G plus F, which is both B and C together. And the last part here is the set which is represented by both A and C. So the overlapping between A and C is shown by the regions E and G together. So both A and C should be taken as E plus G. This is nothing but A intersection B. A intersection B. The intersection of these two circles is D and G. Likewise, this is A intersection C. Intersection of these two circles is the region represented by E and G together. And B intersection C should be taken as F plus G. So these three regions, D plus G, E plus G and F plus G, show the intersection of any two of the given sets. Moving on further, all ABC is nothing but G. If you observe the centermost region here, G is that region which shows the overlapping between all the three circles. If you observe properly, circle A or set A, set B and set C, their overlapping region is nothing but the region G here. So that G is nothing but which shows the persons involved in all A, B and C categories. So that should be taken as G. And the last region here we find is H, which is nothing but the region outside these three categories. So whatever is left out after these 7 regions should be taken as H, and that is nothing but none of A, B and C. So none of A, B, C should be taken as H. And as I've mentioned in the previous case, sometimes the value of H may be 0. For example, let's say each of the persons here is involved in at least one of these three categories. In that case, none will become 0. So if none exists, it should be taken as H. Otherwise, it can be simply taken as 0. So these are the 8 different regions that we have in case of 3 sets. And now, by combining all these things, we can derive a formula as shown here. That is, total should be equal to set A plus set B plus set C minus both of A and B minus both of B and C minus both of C and A plus all A, B, C plus none of A, B and C. Like in case of 2 sets, we say total equals to A plus B minus both of A, B plus none of A, B. So in case of 3 sets, it should be A plus B plus C minus both of A and B together minus both B and C together minus both C and A together plus all A, B and C together and none of A, B and C. And if we try to substitute the variables in terms of A, B, C, D, E, F, G, H in the formula, we find that the total will be balanced as A plus B plus C plus D plus E plus F plus G plus H. So that can be verified simply by taking capital A as A plus D plus E plus G, capital B as B plus D plus F plus G, and capital C as C plus E plus F plus G. And likewise, both AB, both BC, both AC can be taken as shown here. And when we substitute everything in this formula, we find that the total comes out to be the sum of all these 8 regions. As we have discussed earlier, in case of 3 sets, it is always suggested that we go for a Venn diagram to answer the given questions. And remember friends, if we draw the Venn diagram, the first region that we need to fill here is the region represented by G. That is nothing but the region which shows maximum overlapping. As you can see, G is that part which has got overlapping between A, B and C, all of them. So until and unless we know what is G, we cannot fill the remaining regions here. So if we have to go by Venn diagrams, the first region that we should fill here is G. Once we get to know what is the value of G, then we can proceed for D, E and F. And after we get D, E, F, we can fill A, B and C. And at the end, the value of H can be obtained. So that's like an inside-out operation. First of all, we should know what is G. Then we can proceed outwards and fill the remaining regions, D, E, F. And then after that, A, B, C. And finally, we can go for H. Before we take any example, let us understand what are the various types of questions that can be asked in case of 3 sets. Now, as you can see here, let us assume that the 3 different sets represents 3 different categories. For example, A is the number of people who have tea, B is the number of people who have coffee, and C is the number of people who like to have milk. So let's see what are the different types of questions that can be asked in case of these 3 categories. For example, the question may be, how many people like tea? Now as you can see here, T is represented by this circle A. So whatever comes inside that should be taken as the number of people who like tea. So that is A plus E plus D plus G. Suppose the question says, how many people like only tea? Remember friends, the keyword only plays an important role. Tea and only tea are 2 different cases. So the number of people who like tea should be A plus D plus E plus G. And number of people who like only tea should be the region A. Why? Because only tea means what? They should not like coffee and milk. So if we try to take out the remaining 2 circles, the left out region is A. Likewise, the question can be how many people like to have only coffee? Only coffee is B. How many people like to have coffee? should be B plus D plus G plus F. How many people have milk? That should be taken as C plus E plus G plus F. How many people have only milk? That should be taken as C. The other question can be as follows. How many people have all tea, coffee and milk? So all tea, coffee and milk is nothing but the region G. How many people like to have none of these? None of these should be taken as H. How many people would like to have coffee and tea? Now as you can see, coffee and tea means what? Intersection of coffee and tea. And intersection of coffee and tea is D plus G. D plus G. Again here, the word only plays an important role. How many people like to have coffee and tea? We should take it as D plus G. How many people like to have coffee and tea only? When we say coffee and tea only, it means they should not like milk. So that should be taken as the region D. So if the question says how many people want to have tea and coffee, we should take it as D plus G. Tea and coffee. That means here the people can also have milk, but they should necessarily have tea and coffee. So that is D and G. How many people want to have tea and coffee only? Then we have to go for D. Likewise, it can be how many people like to have coffee and milk but not tea. So as you can see, coffee and milk is this region. But because it says not tea, we should leave out the region G. So only left out part is F. So people who like to have coffee and milk is G plus F. People who like to have coffee and milk only is F. And similarly, it can be asked for tea and tea and milk only. So depending on the question, we can just pick up the required regions, add them and get the required answer. Let us now take an example from model 2 of set theory. The question given here is, in a class of 106 students, each student studies at least one of the three subjects, maths, physics and chemistry. 48 of them study maths, 51 study physics and 53 chemistry. 16 study maths and physics, 17 study maths and chemistry and 18 study physics and chemistry. So this is the information given to us, followed by 5 questions, and each question here carries 1 mark. So altogether this is a 5 marks question. Let us see what are the questions here. The first question is, the number of students who study exactly 2 subjects is equal to what? Second question is, the number of students who study more than 1 subject is equal to what? Third one is, the number of students who study all the 3 subjects is equal to what? Fourth one is, the number of students who study exactly 1 subject will be equal to what? And the last one is, the number of students who study physics and maths but not chemistry will be equal to what? So as we can observe, all the 5 questions given here are based on the information given in the question. So with respect to this information, we have to first of all draw the Venn diagram and fill all its regions and then proceed towards solving each of these 5 questions. So let's take up the Venn diagram for the given information. Now as we know, here we have 3 sets. One is maths, the second one is physics and the third one is chemistry. And the total class has 106 students. That means the universal set or the total set is equal to 106. Now the first statement here is, in a class of 106 students, each student studies at least one of the 3 subjects, maths, physics and chemistry. So very clearly, each of those 106 students are involved in either maths or physics or chemistry. They study at least one of these 3 subjects. So very clearly, there is no student who studies none of these subjects. So the region which represents none should be equal to 0 in this particular case, as each student is involved in at least one of the 3 subjects. So let's take the 3 subjects with the help of 3 circles as shown here. The first circle be maths, second one physics, and the third one is chemistry. And we know that the different regions here are A, B, C, D, E, F and G. And the 8th region will be H, but H here is equal to 0, as at least one of the subjects is studied by each one of the students. So this is equal to 0. And the total of all these regions now has to be equal to 106. The universal set is nothing but the sum of all these 7 regions. So total is equal to 106. That is given in the question. Total is 106 students. Now the next statement says 48 of them study maths. Now we know that the number of students who are involved in maths is represented by these 4 regions. So we can say A plus D plus E plus G is equal to 48, as 48 of them study maths. Be careful, it is saying that 48 of them study maths. It doesn't say 48 of them study only maths. Had the word only been given, we would have taken A equals to 48. But because only is not there, the complete circle is 48. Then 51 study physics. So this complete circle is 51. So all these 4 regions amount to 51. And likewise 53 study chemistry. So the total of this circle is equal to 53. Moving on, it says 16 study maths and physics. 16 students study maths and physics. So maths and physics is represented by D and G. So D plus G is equal to 16. Then 17 study maths and chemistry. 17 students study maths and chemistry. So maths and chemistry is represented by this leaf, that is E plus G. So we can say E plus G equals to 17. And 18 study physics and chemistry. So as you can see, physics and chemistry is shown by G and F together. So G plus F is equal to 18. But as we know, to fill the values of each of these regions, we have to first of all find out what is G, the centermost region, or the region that is overlapped by all the 3 circles. And G is not given in the question directly. So with the help of the formula, we have to first of all find out what is the value of G. We know that the formula here is total equals to set A plus set B plus set C minus both AB minus both BC minus both CA plus all ABC plus none. So let us substitute the given values in the formula and find out what is the value of G, or the region which shows all A, B and C. So going by the formula, total is nothing but 106. So 106 should be equal to set A. Set A is nothing but the students who study maths, which is 48. Plus set B is physics, 51, plus set C is chemistry, so 53, minus both AB, both A and B here is nothing but 16, both A and C is 17, and both B and C is 18. So we can say minus both AB, so minus 16, minus both BC, minus 17, and minus both CA can be taken as minus 18, plus all ABC plus none is equal to 0. So this is equal to 0. So by putting up the values in the formula, now we can find out what is all of A, B and C. That means the number of students who study all the 3 subjects A, B and C. So by simplifying this, we find that all A, B, C, or nothing but G, will be equal to 5. Why? Because 48 plus 51 plus 53 will be equal to 152. 152 minus 16 minus 17 minus 18 will be equal to 101. And 106 minus 101 will be equal to 5. So we can say that all ABC, or the region G, will be equal to 5. So now we can say this is equal to 5. Once we know the centermost region, the remaining regions can be filled from the given data. Now as we have discussed earlier, after filling the centermost region, we should now try to fill the 3 regions D, E and F. From the given question, we know that 16 students study maths and physics. Maths and physics is represented by D and G together. So D plus G is equal to 16. As per the given question, 16 is nothing but D plus G. So D plus G equals to 16. Already G is 5. So by taking 5 here, we can say that D will be equal to 16 minus 5, that is 11. So D here will be equal to 11. So 11 students study maths and physics only, but not chemistry. Now, the next part here is 17 students study maths and chemistry. Maths and chemistry is represented by E and G. The intersection of maths and chemistry is E plus G. So as given here, 17 is nothing but E plus G. And we already know that G is equal to 5. So again, by taking 5 here, we can say that 17 equals to E plus 5. So E will be equal to 17 minus 5, 12. So here, E will be equal to 12. The next part here is F, that is nothing but physics and chemistry. From the given question, we know that 18 students study physics and chemistry. And from the Venn diagram, physics and chemistry is represented by G plus F. So this 18 here is nothing but G plus F. Out of which, again we know that G is equal to 5. So by taking 5 here, we can say that F will be equal to 13. Why? Because 5 plus 13 is 18. So the region F here will be equal to 13. Now after filling the regions D, E and F, we now need to go for A, B and C. From the given question, we know that 48 students study maths. And from the diagram, we can say that maths is nothing but the region represented by A plus D plus G plus E. And from this, we can now find out what is the value of A. Why? Because this A will be equal to total 48 minus the remaining 3 regions. So 48 minus 11 minus 5 minus 12. So 48 minus 11 is 37, 37 minus 5 is 32, minus 12 will be equal to 20. So we can say that the region A here is equal to 20. Similarly, we know that 51 students study physics. Now physics is nothing but D plus G plus F. So B now can be taken as 51 total minus these three regions, 11 minus 5 minus 13. So 51 minus 11 is 40, 40 minus 5 is 35, 35 minus 13 is equal to 22. So this will be equal to 22. So this is the value of B, that is the number of students who study only physics. And the last region here is C. From the given question, we know 53 study chemistry. So chemistry again is nothing but C plus E plus G plus F. Already E, G and F is known to us. So C can be taken as total 53, that is chemistry students, minus 12 minus 5 minus 13. So 53 minus 12 is 41 minus 5 is 36 minus 13 will be equal to 23. So C is equal to 23. So with this, we now know all the 7 regions. That is A equals to 20, B is 22, C is 23, D will be equal to 11, E is 12, F is 13 and the region G is equal to 5. Now once these values are known to us, we can quickly answer the given 5 questions. And remember, we also know that H is equal to 0. That means the number of students who study none of the 3 subjects will be equal to 0. Now the first question here is the number of students who study exactly 2 subjects. Exactly 2 subjects. Now exactly 2 subjects here is represented by D, E and F. D is the region which shows students studying maths and physics only but not chemistry. So exactly 2 subjects, maths and physics. Exactly 2 subjects, maths and chemistry. And exactly 2 subjects, physics and chemistry. So the answer for first question can be taken as 11 plus 12 plus 13. This shows maths and physics only. 12 shows maths and chemistry only. And 13 shows physics and chemistry only. And by adding all these 3, we get the answer as 36. So we can say that 36 students study exactly 2 subjects. The second question is number of students who study more than 1 subject. Number of students who study more than 1 subject. Now these 20, 22 and 23 are the values which shows students studying only 1 subject. But we want more than 1 subject. So more than 1 subject will be 11, 12, 13 and 5. That is 2 subjects and all 3 subjects. Already the sum of 2 subjects is 36 from the previous question. So 36 plus 3 subjects 5 will give us the required answer. So this can be taken as 36 plus 5, that is equal to 41. So students who study more than 1 subject is 41. Why? Because remaining students 20, 22 and 23 here are those students who study one of these subjects, only one of these subjects, maths or physics or chemistry. So total of remaining value should give us the answer for question number 2. The third question is number of students who study all the 3 subjects. Now very clearly from the diagram we directly know that all 3 subjects is studied by 5 students. So that's the answer for question number 3. Fourth one here is the number of students who study exactly 1 subject. Now exactly 1 subject here is number of students studying maths only, physics only and chemistry only. So that can be taken as 20 plus 23 plus 22. Why? Because students who study only math is 20, students who study only physics is 22 and those who study only chemistry is 23. So sum of all these 3 will give us the answer for question exactly 1 subject. So 20 plus 23 plus 22 will be equal to 65. So that is the answer for question number 4. And the last question here is number of students who study physics and maths but not chemistry. Now this again can be answered directly from the Venn diagram. We know that number of students who study physics and maths is represented by this leaf here. That is D and G together. But the question says who study physics and maths but not chemistry. That means students should not study chemistry. So if we remove this region, chemistry circle, the region which shows maths and physics is D. So we can say that the number of students who study maths and physics but not chemistry is equal to 11. So this answer here will be 11. Students who study physics and maths but not chemistry. Likewise, students who study maths and chemistry but not physics should be taken as 12. And students who study physics and chemistry but not maths should be taken as 13. So these are the various types of questions that can be asked in case of 3 sets. As you can see, answering these 5 questions here is not a difficult task. It doesn't take any time. But the only point is we should be able to draw the diagram properly and find out all the required regions. So this is how you proceed for solving a question with respect to 3 sets. Remember, always we should know the value of centermost region. That means the region which shows maximum overlapping to fill the remaining values in the Venn diagram. So practice well on this question and make sure that if this comes in the exam, you bag your 5 marks. That's all from set theory. See you in the next session. Thank you.